All right, folks, this is our first lesson in Chapter 10, Section 1. We'll be looking at circles and circumference today. So this is more of an introductory lesson, talking about what a circle is, some different attributes that we see, just some basic problems before we get into more complicated issues. So let's start off. What is a circle? Because again, definitions in geometry are everything. So for us, a circle is going to be the locus of all points in a plane equidistant from a given point called the center. Wow, that was a lot. So let's break it down. The locus. In other words, it's the location of all of the points that are the same distance away from some common point called the center. Notice they have to be in the same plane. So in other words, on the same flat surface. So in other words, it's not like on a rolling hill or anything. And the center point, again, is equally distant from every other point that's on that edge. All right, which means that the distance from the center to the edge, no matter where we measure it from, is going to be the same all the way around. Another ramification of this is that this means that circles are not polygons, because remember, polygons have to have a finite number of sides. And in this case, there are an infinite number of points on the edge of the circle. So again, circles are not polygons by our definition. Some parts of the circle that we need to be aware of. First, that distance from the center of the circle to the edge is called a radius. Again, its endpoints is simply a segment from the center to edge, and all radii are equal. Again, radii being the plural of radius. And we know that based on the definition of a circle, that all of those points must be equidistant, therefore all radii must be the same. A diameter is a chord, and we'll talk about what a chord is here in a second, but a chord that passes through the center of the circle. So in this case, BE is a diameter. A chord is simply a segment that touches the circle twice on its edge. A diameter then, more specifically, is a chord. Again, it touches the edges of the circle there twice, but also goes through the center. Right? And obviously, we would have radii here for CB and CE, both of those being equal in length. That means C not only is the center of our circle, but it's also the midpoint of our diameter. So again, something to think about. Let's try naming some things just to make certain that we understand all the different parts and what we would do. So naming the circle. The symbol for a circle is simply a circle, typically with a dot in the center to represent the center. And we name circles based on the center. So in this case, I could call it circle K, though I think that's copyrighted. Let's talk about the radius of the circle. Obviously, we've got multiple radii that we could name here. And again, we can name them in any order. We could name, for example, K to P. We could also name it from P to K. Both of those would work. So if we're going to talk about radii of the circle, and I'm only going to name them from center to edge in this case, just to have a commonality here, we could have K, P, so that segment. We could have K, Q. We could have K, R, and so on. Okay, and obviously we could have the reverses of those as well. We could have P to K, Q to K, R to K, and all still radii of the circle. But any of those that go from center to edge would work. All right, a chord of the circle. Well, we've got a few different chords that we can name here. So those that are drawn in, we could have NO or ON. So NO, that segment. ON would also work. We could talk about chord RP or PR. Again, the names can be reversed. Obviously, we could draw in other chords. For example, I could draw a chord in from Q to P, P to Q, but obviously that isn't drawn, so not what's being asked. And then the diameter. Well, in this case, for what is drawn, the only diameter that we can see clearly would be R to P. Typically, if you have a drawing like this, it will be specified what is and is not a diameter as to not make you assume things that perhaps aren't true. So in this case, name one of our diameters. Well, the only diameter drawn at this point would appear to be R. P. Notice RP doubles as both a diameter and a chord because diameters are chords. They're just very specific kinds. All right, let's talk about measurements. All right, see if we can do some things with that. So finding radii and diameter measures. Here we go. Circle A, we're told, has diameters of DF and PG. So what I'm going to do is I'm going to grab a highlighter here just to highlight those to show that, for example, DF and PG are indeed diameters. Those are straight lines. They don't have a bend in them somewhere where you just can't see. All right, so let's take a look. If D to F is 10, then we need to find D to A. Well, remember, we said that a diameter would go through the center, and that from center to edge is the same distance no matter what, which means A is the midpoint. So if we know D to F is 10, then D to A must equal 5. And notice, when we're talking about a distance, remember, we don't put the segment symbol up there, again, because we're talking about a measure. The dA, that actual item itself, can't have measure in and of itself. We can talk about its measure, but in and of itself is not a value. Right? So very good. Let's talk about PA. So P to A, that's a radius. It's 7. P to G, notice, is the diameter. So if P to A is 7, that means A to G is also 7. PG would then be 14. And last but not least, AG. So again, there's another radius measure. If AG is 12, what does LA have to be? Well, again, all radii are the same, so LA must also be 12. All right, easy stuff. Let's see what else we got here today. Oh, intersecting circles. Aren't they fun? So notice, we're told that the diameters of A, B, and C, those circles, are 10 inches, 20 inches, and 14 inches respectively. So what I'm going to do is just above here, I'm going to write 10, 20, and 14, just to help me remember. I don't really want to diagram it in here just because I'm afraid that'll get complicated, but I do want to have it out here just so that I can see that, yes, this diameter is 10 or this diameter is 20 and so on. So let's find X to B. So X to B is just this segment. I notice, for example, that A to X is a radius of the smaller circle, so it's 5. All right. I know from A to B is a radius of this larger circle, okay, in this case being 20 overall. So if this is 5, that must be 10, which means X in this case would be, well, halfway, right? If this is overall 10, but this section being 5, this overall is 20, with this section being 10. We've got 5 and 10, so X to B must be 5. So XB must equal 5. Did they give us a unit? Yes, they did. Inches. 5 inches. Cool. All right. Now we need to find BY. All right. Let's take a look at that. I know that for circle C, its whole diameter is 14, which means Y to C is 7. Again, B to C would be 10. Again, half that distance is 10. So I've got 7 here, 10 there. Overlap would then be 3 inches left. So B to Y is, oh goodness, what did we say? I've already forgotten. 10 in steps of 3. There we are, 3 inches. Goodness, it's early this morning. I don't know what I'm doing. There we go. Simple enough. Well, if we can find those kinds of measurements, then let's see if we can ramp it up a bit. Let's talk about circumference. All right. Circumference is not the name of a knight. Circumference is simply the distance around a circle. In other words, it's the perimeter of the circle. We got a couple of different formulas that we can use to help us find circumference. If C is the circumference of our circle, and we've got either diameter or radius, then here's what we can say. Circumference is equal to pi multiplied by the diameter. Okay. Another way of saying it, since diameter is made up of 2 radii, then we could say 2 pi r. In other words, 2 radii equaling that same diameter. So these two formulas are indeed the same. There's multiple different ways to prove this particular circumference formula rather. I'm not going to take time here to do it. We'll talk about it when we come to class. But just know either one will work. Personally, I use whichever one that I have the information for. So for example, if I'm dealing with a diameter in a problem, well then cool, go ahead and grab for this. Or if I know the radius, okay, fine, grab that. Either way, you're going to get the same number. One thing I would caution you on is pi. All right, pi is approximated a number of different ways. If you use a calculator, for example, and we hit the pi button, well, maybe if it'll let us. There we go. And hit enter. Notice all of the digits of pi that come up. Again, that's the calculator's approximation. Remember, pi is irrational. It goes on forever. It doesn't repeat itself. Some textbooks or some tests will not have you use your pi button. Some of them will only have you use the approximation of 3.14. If you use the pi button, your answers, in theory, depending on what you're doing, could be larger or smaller than what is being asked if they want just 3.14, again, depending on the math that you're doing. So again, pay attention. What version of pi is being asked for? If nothing's told to you, then you can use that pi button. That way you just have to push one button and you're a little bit more precise. If you are specified to what to use, whether it's 3.14 or some other variant, then make certain that that's what you use. Otherwise, the answers that you get are off, and I'd hate for you to be wrong about something as silly as that. So let's try some of these, see what we can do. So let's look. We need to find the circumference in this case. Find C if R is 7. So finding circumference, again, pretty straightforward. We'll take 2 times pi times our radius, and in this case, that is 7. Now, just to show you the difference, and again, a lot of times the differences aren't much, but let's talk about them. Let's use 2 times 3.14 times 7 and just see what that answer gives me. So one option is 43. Let's see, didn't specify what to round to. 43 point, we'll go ahead and just give it everything here, 96 centimeters. And remember, we're finding a distance measure here in circumference, not an area measure. So it's just centimeters, not centimeters squared. All right, let's try it again, this time with the pi button, just to show you the difference. So notice, same tens, same ones, same tenths. It's not until the hundredths position that we start to see an issue. And you might think, well, good Lord, the hundredths issue, we're only 2 hundredths off, so to speak. What's the big deal? Well, this is a fairly small circle. The larger the values we get, or when we start getting into area, these differences start to compound. So again, pay attention. This could be the difference between you getting a good answer versus you getting a bad answer. And again, I'd hate for you to do something silly. For what I'm going to do here, I'm going to keep using 3.14 for no other reason than it gives me a nice, neat number. But again, make sure you do pay attention to what we're going to round to. All right. So let's try it again. We're going to find circumference if our diameter is 12.5 inches. All right. Well, the difference in our formulas there is pretty straightforward. We'll have pi, and this time multiplied by our diameter. So in this case, 12.5. So when I type that into my calculator, 3.14 multiplied by 12.5, we get a nice, neat number, 39 1/4. So 39 1/4 inches. Easy enough. All right, well, let's go the other direction. All right, what if we're given the circumference and they want us to go back and find the diameter and the radius? In this case, we are specified what to round to, in this case, to the hundredths position. All right, well, let's write it out. And we'll do it in both formulas just so we can see it done. So 136.9 meters, so that's our circumference, is equal to 2 times pi times our radius, and we'll solve that here in just a second. The other version, 136.9 equals pi times our diameter. All right. I'm going to start here, and you'll understand why in just a second, for the simple fact that there's not near as much to do. In order to get my diameter, I'll just take the circumference and divide it by pi. So let's do that. Let's take 136.9, we'll divide it by 3.14, and in this case, we get, oh goodness, that's not a fun number. Again, asking to round to the hundredths position, so it looks like 43.60. And again, we could drop the 0 in theory. So diameter is equal to 43.60 meters. Again, rounded to the hundredths position, technically that is how we would need to write it. Cool. Well, now that we've got that, great. How would this be any different? Well, the only real difference is not only would I take my 136.9 and divide it by pi and get that fun answer, but then I would take it and divide it by 2 as well to get the radius. Because remember, radius is only half the length. So in this case, if we were, again, round to the hundredths position, we get a radius measurement this time of, what is that, 21.80 meters. Cool. So again, use whichever formula you need for the moment. In this case, since we had to find both, an easy way to do it would just be to use this version, get your diameter, and then have that, and you're home free. If you have any questions or concerns, please bring them with you to class. I want to make certain that this opening day for Circles is one that's easy enough for you, that you understand the material, because where we're ultimately going to end up by the time we're done with our Circles unit is into some pretty heady ideas, and I don't want you to get off on the wrong foot. If you have any questions or concerns, again, bring them with you to class. Otherwise, we'll see you then.